Okay, let's see if we are connecting fine to YouTube. Yeah, I think we have 20 people and we are live. So let me just start my slide deck. Perfect. So welcome everybody, wherever you are. It's also like one of the benefits of actually doing it like virtually. Let me just shortly check if I can also see. Yeah, microphone also on. Okay. Yes, so everything is back live. So welcome to next edition of actually August of 2020 of Hacking Machine Learning. And today we have two pretty amazing speakers talking about NLP in production. And for me, it's really interesting because, I mean, we had pretty diverse topics, right? Like last time, one of the last times we were talking about robotics, right? We talked about many times about some image processing, right? And computer vision topics, right? And many of us, and as humans especially, we're really interested about like language processing, right? But even given the progress that we have seen in academic language processing, right, but also with more applicable and pragmatic language processing, right, it's still pretty open question how to bring it to production, right? So if you have, you know, like a good embeddings, right, and contextual embeddings, and you're actually using them in production as a part of business solutions, also two different like animals, right? And for me, it's like really interesting today here two completely different stories, right? From maybe a bit younger company, from my understanding, I might be like missing that out, but like really innovative as Rasa in Berlin, right? And something that is like really well-established companies, AutoScout, right? But they still use like quite a bunch of like advanced technologies, right? That's why I'm like really interested to see our speaker selection today and yeah, see what they're going to show to our audience, right? What is also a slightly different format today is we're not only going to do the talks, right, that you can see or you are watching right now on YouTube, but we also do a bit of like hangout party in Google Meet, right, and Google Hangout. So essentially what's going to be happening is closer to the end of our presentations, I'm going to share a link inside of YouTube, right, comment section, or also on Meetup, and after you'll be able to join and ask your questions, right? But it doesn't really mean that you need to hold on to your questions like till like very end to this like hangout session, right? Please ask them like in a YouTube comment section, right? So those questions can be answered, right? And we can also share it for other people. What is this like Google Meet or Google Hangout discussion is more if you go to the conference or you go to the meetup, right? And the end, you can go in this like a small circle of people and you can just like have more close connection, right? And a close conversation of those things, right? And this is what basically Hangout. So if you have questions like more connected and directly connected to the topic, please write in the comments. And if you just want to have a conversation and ask, you know, like more interactive questions, just like wait for Hangout party like later on. Yeah, so one more time, what is Hacking Machine Learning? This is a meetup that I created in 2017. It's funny, it's been already like more than 3 years. But the idea of that being, we want to focus a bit more on practical aspects of machine learning, right? There have been like many theoretical topics, right? And people always talk about machine learning because, you know, it's like one of those fancy topics. But we wanted move it from domain of just like talking about that to actually making it, right, to getting our hands dirty, right, and bringing them to production. So it's actually our idea, right? We did some workshops, and today we're bringing also like more hands-on experience from bringing it to production. We also have a Slack channel. You can also, you know, join the Slack channel. Sorry, I kind of lost it. Sorry. I have like some technical difficulties with my screen. Yes, so we have a Slack channel, right? And the idea of that being that you don't do it like once a month, you see each other, right? It's just like that you can follow up on this conversation, right? And it's been like especially from my point of view, interesting idea once you do it like in offline meetups, right? Because maybe that you meet this person like once a month, right? And you wanna, in order to increase the surface of your learning, right? You want to increase also like amount of iterations that you're having on that, right? So having Slack is basically being able to have this conversation not like once a month, but more like every second day, right? And after pushing it forward a bit more. That's also a bit of to before times, and we used to get together in different offices, right? Get some cold beers and hot pizzas and talk about some topics related to machine learning and data science, right? This is like one hosted by Stylight back in Munich, basically. That's how it looked like, I guess, in April for me, right? Just some laptops, right? And see my fellow speakers, and we have like good time. But don't get this change of the world around you, right? To change your learning curve, right? And you stopping to innovate, right? So be still creative and learn some new cool topics. I still have like GitHub page when I'm uploading slides. It's most likely not all of the recent ones, but please ping me and I can definitely like push more of recent talks, right? If not, you can still follow the speakers on whatever social media they're using, and they like usually pretty happy to share those ones. So back to the topics from today. Today, as I said, like two exciting topics. One is about like processes at Rasa, and like how Tanja and her team is basically, challenging it more from product ideas to actually bring into production. And what is this like whole life cycle? It's like really interesting also for me, because many things, unfortunately, it's not about just like pure scientific problem and scientific solution, right? But more about us actually figure out like how to get it to the business, right? How to get the like value out of that. And Tanja does show like some connections, like how to give this like science and advanced technology a bit of a human face that people can understand and can champion behind your ideas. And after Markus is going to show a story of like AutoScout and how they use like transformers in the world, and how those are also like helpful. So and I think it's like really good also connection topic, right? Because everybody's talking about transformers, or like even more advanced one like BERT, and like how this like is solution for all problems, or I don't know, even GPT-3, right? But very few people actually understand what it takes to bring it to production, right? And what technical difficulties you are having there. So that's like where I hope Markus is going to show quite a bunch of like cool ideas and cool solutions. Yeah, so usually if you do it offline, we also have some people that supporting us. They can do like pizzas, they can do locations. Right now, cost of running event is definitely smaller, right? Because for that, I need to have stable internet connection and amazing speaker to support me. But if you or your company would like to, enable your machine learning community, right? It's a local, I don't know, Munich, Berlin, whatever you name it, or global, please approach me and we can find what is a good way to engage with such community, right? Maybe you're going to have, I don't know, some remote pizzas or beers, right? It's just like all open for full ideas, right? And as I said, right, it's all about actually enabling and paying forward, right? So please reach out if you actually have some cool idea that you would like to support, right? So usually we also try to announce a bit more upcoming events. Right now, I don't really have like the next dates, but I have some conversations some other speakers. But in case you have something cool that you would like to share, working on and how to structure it to get like a bit more interesting topics. So months into the topic, definitely going to save at least those couple of months, right? By now, you're only like saving quite a bit of time for humanity, right? So don't be shy, don't be a stranger, and just like drop by to share your knowledge. With that, I'm kind of like done with my part, and I'm super excited to welcome on our virtual stage Tanja. So just give me a second, and I will do the transition. Cool. So I'm adding Tanja. So now you're live, and your screen can go also here. So with that, please take the virtual microphone, and you're.
Hey, hope everyone can hear me. Thanks for the introduction, and thanks for having me. Welcome to my talk from research to production, our process at Rasa. My name is Tanja. I'm a machine learning engineer at Rasa, and in this talk, I'm gonna cover first what is Rasa, who we are, just a short introduction so that you know what we're actually doing. And then I'm going over to a short case study. So I'm going to show you an example of a research feature that we recently shipped. And that basically I'm using throughout my talk in the main part from research to production, where I show you basically how we at Rasa come from an idea to an actually shipped feature in the end. And in the end, I will give you just a short summary. Okay, let's start by introducing Rasa. Rasa is a startup in Berlin, or I'm sitting in Berlin, but we also have offices in Edinburgh or San Francisco, or maybe they're actually closed right now because of the pandemic, but hopefully they're going to open soon again. We're around 50 people, and this is us on the offsite. So we meet twice a year offsites in some city in Brandenburg, actually in Germany, where we all get together and have the chance to chat. And this was before the pandemic in January this year. Let's see when we have the next one. So what we are doing. In Rasa, we are building the standard infrastructure for conversational AI. And we believe that this is best possible by using open source. So the main product we have is open source, and that contains basically everything you need to build your own conversational AI assistant. And then we are glad that we have such a huge and engaged community, actually. We put a lot of effort in growing this kind of community and educating also them and teach them stuff and help them grow. And then the third pillar is basically applied research, which is important to improve the product and to get ideas from the latest research to make the product better. And because without AI, basically, conversational AI is kind of not working, right? So that's also one important part that we are doing. Just a brief overview of what Rasa Open Source, so the core product, looks like. Rasa Open Source is a tool for developers to build text and voice assistants in-house, and it's basically consisting of two main components. The first one is the NLU component, short for natural language processing, natural language understanding, sorry. And it's basically there for taking the incoming user message. So for example, if you look here at the right, I want to order pizza. That's the incoming user message, and this component is then responsible to identify the intent of this message and, if possible, also extract any entities which are in the sentence. So in this case, I want to order pizza, which should have been classified as order pizza intent. And then we have the core part, which is basically our machine learning-based dialogue management. So this component is basically responsible giving the conversation history, so everything that happened before, and predicting what should happen next, so what kind of action to perform next. So if you look at the dialogue here at the right, everything is basically taken into account, and then the core dialogue management system needs to decide on what kind of action, like on the bottom here, it should perform next. So, and basically then it picks the most likely one and actually performs it. So in this case, it would be list toppings. Let's go one step further. So how does the whole conversation flow then look like? So basically the user is saying something via text or via voice. So you can basically use any kind of channel, be it Slack or Skype or WhatsApp or whatever. And Rasa is basically then connecting to this channel and retrieving the incoming user message and forwarding it to the natural language understanding component. So the component that is then responsible for identifying the intent and the entities. So those are then moved forward to the dialogue management system, which is basically the core component, right? So it basically takes whatever was said before, or the conversation history before, plus also all the intents and entities that were detected, and predicts then the next action. And if necessary, or sometimes the next action actually includes something where you have to talk to some kind of backend, some kind of database, or you have to make an API request or something like this. So that's also happening then right there. And so it's basically pretty flexible. You can basically plug in whatever you need, actually. And then once the action is basically performed, we actually have to respond back to the user, and that's basically happening then in the response generator. Currently in Rasa, we don't generate any text, so we are using templates for that. So we have predefined templates where we just fill in some blank values sometimes, and to make sure that the sentences are like looking nice and are coherent, basically. And then the output is basically going back to the user via the same channel as the incoming message. So in this case, I want to change my address, would result in a response like, what's your new address? That's just a quick overview of Rasa, what we are doing and how it briefly looks. And now I'm going to jump over to the research feature, which I want to explain you a bit more. And therefore, we just start by looking at a conversation. So this is a conversation between Carbonbot and me. Carbonbot is an assistant that we built at Rasa. It's an assistant that helps you to calculate your offset and offers you then to calculate your emission and offers you then to buy some offsets to reduce the greenhouse gases. So first, the bot is introducing itself, and then it asks me if I'm interested in calculating my flight emission, which I answered here with yes. And then it asks me a couple of questions in order to calculate then the emission. So it first asked me, were you traveling in economy class, which I also answered with yes. And then it asked, what city will you be flying from, where I'm saying I'm flying from Berlin to London. And then basically the assistant has everything it needs to calculate the emission, and then it informs me that flying from Berlin to London emits 0.6 tons of CO2, and then it offers me to buy some offsets. I want to focus on entity recognition because that's basically where our new research feature is basically targeted at. And so entity recognition or entity recognition is the task of defining and extracting entities from text. So stuff like person names or location or organization names. And whatever entities are extracted by the NLU component basically can then be used later on in the assistant when you, for example, talk to a backend or something. And in this case, the Carbonbot needs to know the departure and destination city in order to calculate the emission. So if you have the sentence, I'm flying from Berlin to London, in a typical scenario, you would annotate Berlin and London both as cities because they are cities, right? But that wouldn't be enough in this kind of situation because we actually need to distinguish between the departure and destination city. So Carbonbot wouldn't be able to calculate the emission if we just would label both as cities. And that's exactly where the research feature we built comes in. So it's called entity roles and groups, and it basically allows you to assign a second label to a token. So if we look at the sentence again, I'm flying from Berlin to London, you would still annotate both as cities as they are sharing some kind of common features, right? But if you look closer, they basically play a different role in this kind of sentence. So the role label is basically saying that Berlin is, in this case, a departure city, and London, in this case, is the destination city. So it's basically both are still cities, but they're playing a different role in this kind of sentence. And then we also have the group label, which can be used in a slightly different scenario. So, for example, if you have the sentence, give me a small pizza with mushrooms and a large pepperoni, you would annotate, typically you would annotate small and large as size, and then mushrooms and pepperoni as toppings. And the system basically in this case needs to order some pizzas in the end, right? So we need to somehow distinguish that small and mushrooms belong together and large and pepperoni, and that the assistant is in the end not ordering a small pepperoni pizza and a large mushroom pizza. So for that, we can basically use the group label. So that allows us to group certain entities to make clear that they belong together, and then the assistant basically knows what kind of pizza to order in the end. Great. Cool. So let's move on. And so that's the research feature we recently shipped, or we shipped in March, I guess. And I want to show you now on this kind of example how we came from the actual idea to the shipped feature in the end. On the way, we have roughly 8 steps, and I'm going to walk you through each of them now and explain them in more detail. So let's start by the idea. Our idea can come from various sources. First, basically community and customers. So community and customers, they basically communicate to us via our GitHub issues or via our forum, and they point out stuff which is not working, which they expect to be in our product, or just basically something which they saw on a competitor software, which is not basically possible in our product. So they basically just point those things out and ask us if we can have a closer look into that. And then we have the literature. So if there's something like a recent paper we read which sounds interesting and is something that we think might be worth trying out and to integrate into our product, we will take a closer look at that and also try that out. And then we have also internal. So if there's something that we think that would move our product further in a certain direction that we want to grow, we basically also take a closer look from the research point, basically, and see if we can do something to support from the research side the product to grow in this kind of direction. The idea of entity roles and groups came originally from the community. So basically last year in June, a community member posted a GitHub issue and asked about this kind of feature, if it would be possible to basically get this implemented in Rasa. Back then it was still called composite entities, so the name changed over time, but in the core idea was basically the same, although we had some kind of iteration over the feature, how it would actually look like in the end. But the original idea that came from the community itself. So once we have the idea, we go ahead and write a research proposal. A research proposal is basically a document where we define the scope of the idea of the project we want to work on, and write down certain criteria that we need to keep in mind when working on it. Normally, we start before we actually writing this proposal. We start by getting more familiar with the topic itself. So we are reading more literature, be it papers or blog posts, so that we are really into the topic and that we know what kind of stuff is already out there. Maybe we can actually reuse something. And then basically once that is done, we go ahead and write the actual proposal. Sorry. This is actually a quite formal process because we have a layout basically for the research proposal, which looks roughly like this. So the research proposal should contain a proper description of the problem, of the idea that you want to do. It should also include the aim, so what is actually the target of this. And also it should contain a list of criteria when you are saying that this idea is actually working and when this idea is actually not working, which is quite important because I guess in machine learning, you all know, sometimes you have an idea in your head and theoretically it should work quite well, but then in practice it turns out to be not really working. And those list of criteria basically helps us to decide at what kind of in what kind of situation to continue with this idea, or in what kind of situation we basically stop working on it and maybe start fresh with another idea with some kind of different problem. The proposal contains a bit more, so especially non-goals that we don't plan to do, and then some stuff around timing and effort and so on. Once you have written this down, you basically go ahead and discuss it with the research team. So normally this is an iterative process, and that goes like back and forth a couple of times. And then once the proposal is finalized, you can then go ahead and continue the process. The research proposal for entity roles and groups, I wrote that end of February this year, and it also contained like the proper description and then the criteria when you actually want to rule out the idea and so on. I just want to mention the 4 ideas we had originally. So basically implementing those entity roles and groups, we had 4 ideas. Idea 1 was that we actually concatenate the entity and role and group label. So basically that you have that you would have just one label in the end on the model side itself. So basically if you have city and departure, you would just use the departure label in the end. Idea number 2 was to use multiple conditional random fields. So, sorry. The first CRF would be used for predicting the entities. And then you would have another one for predicting roles and another one for predicting the groups. And you would additionally feed the entity label to the CRF of the roles and the groups. The idea 3 was to basically not use CRFs, but instead use like a sigma activation and make it a multi-label problem. So in this sense of sequence tagging, for example. And then idea 4 was to actually adapt the conditional random field so that it can predict multiple labels per token. But we looked into this, and that would be quite a lot of effort to implement. So we basically said, okay, we will not work on this idea unless all 3 other ideas are not actually working. Yep. So once we have the idea and the proposal is basically set in stone, we go ahead and write our first implementation. The first implementation is basically there to verify if the solution is actually working or not. So as I already mentioned, it can be that whatever you have in mind turns out to be not working, and you have to stop because of your rule-out criteria that you defined earlier. So what you want to do in your first implementation is you don't want to write production-ready code, so you don't want to polish code, you don't want to write documentation and stuff like this. But on the other hand, you still want to write code that is actually working, right? And you also want to write code that is readable and that you can, if needed, adapt and like iterate fast on. So you kind of need to find a balance between like writing good and working code and production-ready code. But that's normally quite good. Yeah. And then once you have the implementation, you can go ahead and start with your experiments. For the experiments, you basically take the code you have just written. In Rasa, we actually use branches. So everything we as a research team are working on, you can find in our GitHub on certain branches on the open source GitHub. So if you look around, you may find something which we are currently working on. And then, of course, you also need to do some configuration. So depending on the feature you want to implement, you have to define what kind of featureizers you want to use, what kind of hyperparameters the model needs, and so on. And of course, you also need some kind of data set that you can actually train the model on. Once you have all that, you can go ahead and use the command line tools of Rasa, which is Rasa train and Rasa test, to train and test your model and to get some results. The results we offer have this typical metrics like F-score and accuracy, but then you would also see some confusion matrix, for example, or you actually get a file with all the errors made by the model itself. Once you have the results, you can analyze them and adapt the setup as needed, right? So maybe there's still a bug in the code you need to fix, or it turns out that some hyperparameter wasn't really good and you have to tweak it. So this kind of stuff is basically happening a couple of times. So this process is repeated until you get to a point where you say, okay, I'm satisfied and I can now basically decide what to do. And if you want to rule out the idea and stop working on it, or if you actually say the idea is working as expected, and we can continue the process. Going a bit more in detail for the data set, So finding the right data set is quite challenging for us, especially, for example, in the entity, roles, and group case. I need to find a data set that contains like an entity with a second label assigned to it, right? So you cannot really find those kind of data sets. So yeah, what should you do, right? So in Rasa, we have access to public data sets and data sets that we created by our own, which are also open source, but we don't have any like huge data sets from customers and so on, because they keep the data on their side. So yeah, sometimes it's quite hard to find the right data set that is actually fitting your task. So yeah, if you find a data set that is suitable for the task, you're lucky and you can just go ahead and implement it, right? But if not, you have to think, okay, maybe I can adopt some kind of existing data set so that it actually fits our needs. That's basically what I did in the case of entity, roles, and groups. But if that is also not possible, you actually need to consider if it's feasible to create a new data set from scratch, or if that would just take too long, and you may want to postpone the whole idea and wait until a better data set comes out that is more suitable, and yeah, just wait. Yeah, that's definitely always a challenge that we are facing during this kind of process. Yeah, in case of entity, roles, and groups, we run a couple of experiments on the carbon mod dataset. So that's the assistant you saw in the beginning. So the one which is calculating the emissions. And then I also used the SNPs dataset, which is a publicly available dataset that covers 7 intents. So from booking a restaurant table over asking weather information to playing some music and stuff like this. So it's a broad range of topics, and it contained entities, but no second label assigned to a token. So what I did here is basically we had some kind of entities that were covering time stuff and location stuff. So basically took those and added a second label to all of them, which was working quite okay-ish. And yeah, so basically in the research proposal, we wrote that we want to rule out the whole idea if the accuracy of the model is so bad that it just cannot distinguish between entities and roles and groups. So, and then we also said that we don't want to have a solution that is where the training time is increasing significantly. And our results actually showed on both data sets that entities and roles and groups were detected quite well. So of course, we first took a look at the metrics like F-score and accuracy. And then we also went ahead and looked at the actual successes and errors. And that was quite satisfying. And then we compared the training time compared to just training on entity labels and training on entity labels plus role and group labels. And that wasn't increasing significantly. So that was okay. And also during inference, there was actually no really measured time increase. So all in all, we said, okay, we are satisfied with the results so far, and we want to continue the process. Going back to the ideas, in the end, the idea 2 turned out to be the best. So the one where we used multiple CRFs, one for predicting the entities, and then basically depending on whatever is in the training data, having a separate CRF for the roles and a separate CRF for the groups, where those 2 CRFs got the predicted entity label as additional feature input. Yep. And once we have basically the decision that we want to continue the process, we go ahead and do a production-ready implementation. That's quite easily done. So basically what we need to do is we need to follow our coding guidelines as Rasa, which are basically set by the engineering team. And that includes like polishing code, adding doc strings, adding tests, if they're not any yet, and also adding documentation, which is quite important. And then once that is done, we actually already collect feedback before we are releasing the feature, or at least we try. So we share the production-ready version with some of our community members and ask them to provide feedback before we actually releasing the feature, to have the chance basically to adapt the feature if it turns out that there are some major drawbacks that we didn't saw before, basically. Also, like in general, feedback is really important for us because, as I mentioned, we have sometimes trouble to find suitable data sets to test our features, and having the community testing the features before we actually releasing it or even afterwards gives us the chance to see in what kind of situations the features are actually working and in what kind of situations they aren't, which is actually more important most of the time. So what we, basically when the community members are then trying out the feature, they use various kind of data sets, they use all kind of different use cases, and they can actually see, like run the assistant in a production setup and see what users are basically talking to it and how the feature is basically doing during production time. And that is just not doable by us in the research team. So that's something which we are really grateful of, and that's really, really important for us also. And we also ask always that our community members to support, to give us feedback that is contains a lot of details. So just saying that the feature is working is like great to hear, but it does not help us understand in what kind of situations the feature is actually working and in what kind of situations it isn't. So the more feedback included in the feedback, the more details included in the feedback is actually better. So the initial feedback we got for entity roles and groups was quite positive. One user was actually reporting that the name is kind of confusing. So back then it was still called composite entities. And he mentioned that he understands something different under this kind of name. So he suggested to actually change the name, and that's actually what we did. So we basically went ahead and discussed it inside the team, and then decided to rename it from composite entities to entity roles and groups. And then we had one user who tested the feature on different kind of smaller German data sets. So, and he reported that the training data format and everything is working as expected, and it also looks very promising. And yeah, he was quite satisfied in general. So that was really good. And then we basically decided, okay, the first feedback was already positive, so let's go ahead and actually release the feature. However, we are not releasing a research feature as a proper feature. We are releasing it as an experimental feature. So that just indicates that the feature might be changed or removed in the future. Why is that? It's still for the reason that we are still not 100% clear if the feature is actually working in all kind of setups and working on all kind of data sets. So and sometimes, So we want to basically keep the chance to adapt the feature and to actually slightly modify it, and that's why we basically mark them as experimental features. So normally, what we do, we announce the feature on our GitHub or forum or blog post or whatever, and ask our users to actually try it out and to report back to us with a lot of details, so that we can actually make sure that that the feature is working as expected, and if needed, we actually need to that we can modify it. So for entity roles and groups, that feature was released in Rasa 1.10. So I think it was beginning or end of March. And what I did is basically I wrote a forum post about it. So I wrote a short explanation how it works, where you can actually use it, and asked the community to try it out and give us feedback. And that's exactly what they did. So we collected so far quite a lot of feedback, and overall it's pretty positive. So most of the users are pretty grateful and like the feature as it is. But then you can also find some comments that are more negative. So for example, on the bottom left here, one user reported that the feature is actually increasing the training time of the CF entity extractor, which is one of our two entity extractors that is using this kind of, or that's implementing this kind of feature. So that's something we didn't saw during our tests, but that's something we definitely need to investigate. And then another user is reporting that in some situations the feature tends to overfit to certain names to certain row labels or group labels. So, for example, like in the city and city departure and city destination scenario, sometimes you see that, for example, Paris is always annotated as departure city, and London is always annotated as destination city, no matter how the sentence is, basically. So that's also something we definitely need to take a look at and need to find why that actually happens. So basically this is, we have now released the feature, and now we have basically to decide what to do next with it. So as I already said, we are collecting basically user feedback, and depending on the user feedback, we then can decide if we want to adapt the feature or if we actually need to remove it because it turns out that it's completely not working as expected. So basically in the case of entity roles and groups, we need to improve which basically the two things I just mentioned. So that's something I'm currently working on. So I'm currently investigating why the training time of the CF entity extractor is increasing, and also if that actually happens also with the other entity extractor that we have. And then I'm also looking into ways on how to improve this kind of overfitting. So basically what we want to try is we want to try out masking or even like removing the the features from the token itself when we input the feature when we input the features to the role CF or the group CF, so that the CF basically has to focus more on the words right and left of the actual token that is the center basically. So that's something which is still ongoing, and depending on the output, we then have to decide on whether to keep the feature or if we actually need to modify something else, or if adopt it, but maybe we actually need to remove it. But yeah, I hope that's not the case. So that was the journey basically of an idea to the actually shipped and released version. So we went over the idea, which can come from different kind of sources, to the research proposal, which is a quite important and crucial step for us at Rasa, as it defines the scope of the research project we want to work on. And also it defines some kind of criteria that is defining basically when to say that the feature is working as expected and when we actually want to stop working on it because it's not working as expected. Then we went ahead and saw how we did the first implementation over to the experiments, where we need to look about on the data set. So finding the right data set is always a challenging task. Once that is done and you decided to actually continue the process because the feature is working as expected, you go ahead, do the production-ready implementation, and start to collect feedback as early as possible to make sure that the feature is not only working in your setup, but also working on a broader range of use cases and data sets. And once that is done, you can go ahead and release the feature as experimental feature, and then continue to collect feedback to decide then in the future whether to remove the feature or to adapt and do a proper release of the feature. Yeah, that was my talk. Thank you for your attention, and I'm open for questions now.
Yeah, it was an amazing talk. Definitely enjoying different, on one hand, like a different approach, right? To look at to look different angles to look at the problem, right? Because I mean, sometimes people just like looking at the scoring and be like, hey, I improved it like by 0.1%, right? And I was like thought and be like, does it like help anybody, right? So it's definitely really cool. Yeah, I have a couple of questions maybe while people still catching up with all this like content. So one is like pretty. I'm not sure if generic is the right word, right? But how your teams are structured at Rasa, right? Because I know that you do like more, like machine learning, and imagine that there are like people who do like more data engineering side, right? Or, like a pipelining of all those things, right? So if you can, I'm not sure how much you can disclose, right? But just tell us a bit more details. What is the general structure maybe of your team, right? Or like Rasa team, and how closely you collaborate between each other, because it sounds like really fascinating topic as well.
Yeah, so basically the research team is taking really care from the idea to the shipped feature. So we basically in the second part where we do the production ready implementation, we engage together with the engineering team. But in general, you as a researcher, you're also responsible for producing production ready code that is then actually shipped, right? So there's no clear team, or we don't have separate people for implementing what you as a researcher come up with. That's your responsibility as a researcher. And the engineering team, so we have an engineering team and the research team. And the engineering team is more working on such things like connectors to databases, security stuff, and making sure that our Rasa X, basically the product on top of Rasa's open source, is basically working as expected, and you're taking care of those general like architecture things, I would say. And the research team is then more like for the whole data pipeline that's basically owned by the research team. And when there's something we need to modify, then also the research team will do it. Of course, we always collaborate in such cases with the engineering team to make sure that the structure of the whole open source repository remains like good. And also the tests are working and stuff like this. So we try to include we always basically include a engineering guy basically in our reviews to make sure that we also like really proper follow the coding guidelines and stuff like this.
Mm-hmm. Well, what do you think is like a ratio from I don't know, is this like 50-50 engineering like research, right? Or more like 80-20 and majority of people are like researchers? So like how is the distribution for that?
So I'm not sure about the size of the engineering team, but I would guess maybe 15 people, and then in the research team we are around we actually 8 soonish. So yeah, nice. Kind of 2/3, 1/3, kind of
yeah. Nice, pretty cool. We got a question from Barbara, and she's asking that you also working on Flair. Can you talk a bit more about that? And
Unfortunately, not anymore. I don't have time to keep up with that. But I know that Ellen is still making good progress on this. But I cannot tell you more about what the recent progress is on this kind of project, unfortunately. Sorry about that.
Maybe from high level, for people who are not aware what Flair does, what was the positioning of this project while you were like still part of a core contribution?
Yeah, so basically Flair is an open source natural language processing library that contains several different kind of models for doing sequence tagging, intent classification. It also has some kind of language models, so you can train your own language model. I'm not sure if Ellen actually did some kind of machine translation stuff already, but that was also something we aimed for. So it's basically a collection of models and which can be really, really easily used. So something in the direction of Spacey kind of. Basically, you can just plug and play basically different kind of things where you can build up your pipeline and do some smaller NLP tasks without actually knowing what goes like behind the picture. Yeah.
Cool. Sounds good. So maybe while people still asking the questions, let me ask another one from my list of things. So you mentioned this like, hey, people can ask the question as a feature request on GitHub, right? And after you can evaluate if you like it and what is the research proposal for that, right? Do you have some kind of like a roadmap, or do you also share it publicly, like a roadmap for the next 6 months, a year, right? And after you just like a cherry picking what is like fitting into that, or you like really open to those like issues and ideas of features, like how proactive you are, / like you have your own like vision, how Rasa gonna look like in a year, 6 months, and after you're just picking like what fits this path, basically, if it makes sense.
It's really hard to plan research, right? So we don't have any rough outline for the next year or so. So we just plan for the next month, I would say, and see what comes next and then what makes sense to do. But in general, so definitely we have like a product roadmap, right, where we want to aim over the next year and so on. But not all the research features we have in mind are actually fitting this kind of view. And that's why we always have some kind of projects that are basically apart from this. And so we are always open to any kind of ideas, basically. So normally the projects we are working on are kind of split. So some of them are actually fitting what we actually like aiming for as product vision at the moment. But then we always have tasks that are more long-term that we think that improve the product in a sense, but so we want to work on them at some time, but it doesn't actually fit whatever we have on the product roadmap closely. But it definitely makes sense in a longer term vision of Rasa, and so we don't have any like restrictions for all the project, I would say. So it's kind of like 50 maybe what we are actually working on, like open for any ideas, and then more restricted to whatever we aim at Rasa. Yeah.
Maybe like a very pragmatic question. So you showed us the life cycle, right, from idea to more like bringing the production and getting like as experimental. How long does it take in your experience, right, for this feature? Because I guess like each of the steps on its own is kind of like not that long, right? But if you really measure, from beginning of the idea, right, to like, hey, like now it's like live and experimental, what time frame are we talking about? Like, I don't know, like in median or like around that?
So for the entity roles and groups, it maybe took like 2 months or something. So it wasn't really a short period. But then we have other projects which actually take 6 months or even longer. So it highly depends on the scope of the project and what things you actually want to include. So I'm for example actually currently working on connecting Rasa to a knowledge base. So actually pretty close related to the next talk, I guess, where we want to translate basically the incoming message to some kind of abstract query language that can be then used to fetch some information from a knowledge base, and then basically also generate some kind of response out of it. And that project is definitely aimed for more like half a year, even maybe longer. So yeah, it highly depends on the project. There's no strict timeline, I would say.
Yeah, no, I mean, it's really cool. Even for, I wouldn't say it's like such a small feature, because it's still, you need to collect the data set, right? You need to frame it, you need to validate all those things. I guess like the time of you moving is also pretty like, it's pretty good for many companies. It's kind of in 2 months, you already ship this entire thing, right? While involving the community, right? So it's pretty good. Yeah. Maybe like one of the last questions from my side is, so you mentioned like open source, right? And people can go to GitHub and see all of those things that you as a company and your team does. And I think it's like really fascinating, right? Because I think on one hand, it's really showing all internals, right? And you can really like understand like how project is moving, like how to enable it. But maybe if somebody of the people watching right now and would like to be like, hey, I really like Tanja, I really like what Rasa does, I would like to contribute. What is like, is it easy from your point of view, right? And what is a good way to support what you do, right, or what Rasa does, and like what are maybe particular easy parts, right, of Rasa, I don't know, ecosystems that are happy to get contributors, right, and like how to get it started, essentially. Maybe they're gonna go and read something and contribute next week, basically.
Yeah. So we actually have several touch points, I guess, where you can start. I guess the best one is definitely when you go to our documentation main page. So there we have, I'm not sure actually how it's called, but I can maybe share the link later in the chat. So over there, you can find all kind of ways how to contribute. We have, for example, a GitHub board where we collect issues that are easy to start with. So stuff like changing a certain parameter somewhere, or like really small fixes where you can get to know the code base a bit. and then you can submit a pull request if you really want to contribute to the code itself. But then you can also go ahead, read the documentation and just make a suggestion over there for like spelling mistakes or stuff like this, if you want to do something like this. And then, so this is more on the code side, on the documentation side. But then you also are welcome to share any slides or any like blog posts or stuff like this of Rasa, basically. So that's also something we really find valuable. And yeah, so maybe I can just share the link later, and then you can find the list of stuff where you actually can contribute and what kind of ways we recommend you to start with Rasa.
Yeah, if you're going to share it with me, I'm happy to like share it afterwards and meet up and like elsewhere basically as well. Yeah, awesome. It was a pleasure having you. So I think I'm done with like question part right for now. So thank you again for joining. And after we can definitely have like a short hangout party when people maybe going to be like a bit less shy to ask questions directly. Cool. Thank you again, Tanja, and talk to you in after this like talk of Markus basically going up next. Thank you.
Thank you.
I think we got a question. Very last question was from Stefan, because YouTube is basically running, as we said before, a bit late. So just to answer a question from Stefan Nosovic, I guess I pronounced it properly. Have you looked into creating a knowledge graph semantic web as a knowledge base for the bots? I guess it's connected to your recent project, right? And if you have any pointers that are helpful.
Not yet, actually. So what we assuming is basically that the users have already a knowledge base in place. So we are not aiming to create something from scratch on our side. But of course, I guess there are several papers and also projects that actually do what you have asked, basically, like taking a web page and creating some like extracting entities, connecting them via relations, and basically forming them into a knowledge base. But we are not actually working on this kind of things.
And I think there was also just recently a paper by Google Brain, right, when they also do like a similar, like knowledge indexing and trying to find like what is the biggest similarity of the question and data set. So it feels like it's like the next steps. Like once we already got like, okay, we understand the questions, right? It's like, hey, how do connect it to actually like more structure, like a data around that, yeah. So hopefully going to be a bunch of research there. Cool. I guess now it's definitely the last question from the audience. So we let you free and let's talk to you later. Thank you again. Cool. It was amazing first talk. And now we have, last but not least, one from Markus about even more things in production. So how's it going for you, Markus? Is it good? Like, was a good day as well?
Good day so far, yes.
Nice.
Very happy
so yeah, it's amazing to have you as well. And we already had like, I think like on LinkedIn, we talked about your talk already for quite some time. So now I'm finally like happy to share your talk with this community. So I'm adding your screen and the virtual stage is yours. So please welcome Markus. Round of virtual applause for you.
Thank you, Sergey, and hello everyone. And thank you so much for tuning into the live stream. My name is Markus and I'm a senior data scientist at AutoScout24. And today I'm going to talk about the journey of going from an idea to product. It's the journey of building a new feature that is based on natural language processing and shipping it to our users. And what it really is all about is going from a search entry that is very structured and dominated by radio buttons and drop-down menus to something much simpler, namely a text field. And the idea here is to offer something to our users that doesn't require them to think too much about filters and where to find them. Ideally, they can simply type in what they're looking for, and we select the right filters for them. So this was the idea and the product that we built, and the talk today is really going to shed some light on this entire journey. I'm not only going to focus on the technical stuff, but also about things that I'm currently worried about and thinking about, and they actually don't have to do anything about how many transformer blocks do I stack or how big should my embedding size be. It's really other questions, and so I'm very excited to talk to you about that. So maybe just to kick things off, what do we mean by a query, or what kind of response would we like to see? So ideally, we would have a system that, given this input string, would say Audi is a make, R6 is a model, performance is a version, panorama is an equipment, and 2018 is a first registration. So if you think about productionizing such a thing and putting it behind an API, what ideally would happen is the user types in a string, that string gets sent to the API, and the API responds, in our case, with 3 filters, 1 keyword, and 1 range query. And so I want to quickly show you a couple of examples from the live system before we delve a bit deeper into how we built the thing. So these screenshots are from the iOS app, which now includes this search entry. And the first example is very simple. It just shows a model. So you can just type in a model, and the system will typically be smart enough to realize what kind of make this is about, and it just will fire the query for make model combination. In the second example, the query contains a make, a model, and a version, and that's properly mapped. And what's actually cool about this is the model actually needs to learn about what kind of inputs make sense as a version field. And I remember when we built the first model, initially it was very brittle. It basically got freaked out about all kinds of inputs it hadn't seen before in the past, and it would just put them all into the version field. And now many iterations later, the model is fairly robust. So some users mistake us for Google, and they would type in the name of our competitors, and the model would kindly ignore this input these days. Also, if you just look for something that's completely not related to cars, the model would ignore these parts. It will just try to make sense of the things that in the context that we're in, which is typically car search or bike search, can be mapped to filters or keywords, and it will try to set those for the user. And the last example contains just a make and a range restriction. So here the user only looks for cars before 1970. And of course, you can think about all kinds of different range restrictions. This could be mileage, price, horsepower, and any combination of those. So this is kind of the system we built. And as I said before, the idea is to provide an alternative search entry to our users that's a little bit more friendly. It's a bit more intuitive than if you have to dig through all the filter options. And ideally, you can just type in what you're looking for, and we do a good job mapping this for you. So as I said before, this is about the entire journey from idea to product. And this thing really started 2 years ago. And that's also why it's kind of a good time to give this talk today. Today's talk is actually an updated version of a presentation that I've given about a year ago in Barcelona for the Data Council conference there. And quite a few things happened since. And so I'm happy to give an update on the things that I'm thinking about these days. And as I said, it started all 2 years ago with an ideation session where project managers and engineers would just come together and think about new features that we could build, new features that would make the life of our users easier. And that's the first time when this idea popped up to offer a text search. Now, some of you may think text search is not really that special. We've known this in the form of, let's say, Google for 20 years or so. But in our case, it's actually not just keyword search, because we have over 2 million listings across Europe. And if you're looking for a car, you need to bring this down to a reasonable number. And so you need to filter. At some point, you need to filter, be it by make, model, location, price, mileage, just to reduce the number of options, and then you can start contacting the seller. So the question itself is actually a rather interesting one, which is, how do I go from natural language input to something that then displays a relevant subset to our users? And as I said, the ideation session happened in August, and there were no immediate action items that we derived. The next thing that actually happened was a hack week session that we had, I think in September. And here one of our engineers picked up the idea. He also was one of the originators of this text search feature, a very strong proponent even in the ideation session. And he built a simple prototype. Now, this prototype did not use any machine learning. I think what it actually did was it tried to identify make, model, and equipment from a text input string. And you can actually do this if you think about a dictionary lookup or kind of a regex kind of approach. This can be done fairly easily, and he built a really, really nice demo. And that really helped convince the PMs that this feature would be of interest also to our users. It always helps if you can build something and then show it to people to just get buy-in. So this was actually the first thing that happened just a few weeks after the ideation session, was this little demo prototype for the Hack Week that did not use any machine learning. Now I started myself thinking about how could I do something with machine learning to support this project, which hadn't officially kicked off. It was just an idea back then. And apart from thinking it was a really interesting feature for our users to make their life easier, I was also really interested to work with text, because that's something that I hadn't done yet. So in the past, I worked with structured data, images, and also tabular data, so event data for recommendations, for example, but I've never worked with text. And so to me, this was a very interesting problem, and I started thinking about and also reading up on all the advances in NLP. If you remember, summer 2018 was kind of the time when I guess most of us realized that there's huge shifts and massive progress happening in natural language processing. And so this is a time that I always love, and I love when I have the opportunity to take a problem and just think about it and kind of turn it around and look at it from different angles. And there's no time pressure, there's no deadlines attached yet. So I was working during the daytime on other projects, and this was just something I would think about in the evening and read up on NLP on the weekends, just thinking what could be done and kind of catching up on all the research from the simpler things like word2vec and glove to then LSTMs and bidirectional LSTMs. And then all of a sudden, I stumbled across transformers. And this was also around the time when the BERT paper came out and everybody talked about these encoder representations that are super powerful that you can get out of these systems. And while I was initially thinking that I could possibly use something like BERT to embed both the queries and also our items in a vector space, and then kind of do a nearest neighbor search in that vector space, I quickly realized that if I would follow down this approach, I would build a competing search stack, complete different way to basically filter for listings than what's being used on all platforms. And also it would lead to kind of a dead end. So if, let's say, I surface some results based on this nearest neighbor similarity in this vector space, possibly created by a BERT embedding, and the user then wants to add a filter, let's say, for a color or for a range restriction, there's really no easy way to do that. And so I discarded that idea. And then I started thinking, and initially I wasn't even sure if this is a good idea or just plain stupid, if I could use a transformer to translate essentially from natural language into a structured search query. And this was based also on having read the original paper, Attention is All You Need. And what really struck me about this is we now have such a powerful tool that allows us to go from a variable length input sequence to a variable length output sequence. And it doesn't really matter what you map. So you can map from one language to a different language. There was also a really cool application coming out of Google Brain where they took the links, so the links in a Wikipedia page, and they tried to reconstruct the Wikipedia article based on the content that is referenced in the links down there. And that really blew my mind. So with these encoder-decoder architectures, you can really map anything to anything. And that's a very powerful insight. It's a very powerful tool to have in your tool belt. And a couple of applications recently also went into this direction of just basically stepping away from established ways to think about this. So the canonical application, of course, is translation. You go from, let's say, a French sentence to an English sentence, but you can do way more. You can do summarization. You can even do mathematics. I think a couple of months ago, beginning of 2020, Facebook research had a paper where they showed that they trained a transformer to actually be better at doing symbolic mathematics than the official software tools that have been out there for decades and really refined on this domain. But anyway, this was back in 2018, and the main application was translation. And it was just this crazy idea. Maybe I can take natural language input and produce a structured query. Now, the thing is, if you want to train such a system, what typically happens is you need a parallel corpus. That means you have two documents, and there's a line-to-line correspondence between the source language and the target language. And you need quite a few of those, and then you can kind of train the system. The beauty of the transformer is really that it allows you to train these things end-to-end. So in contrast to more traditional NLP, where you would have this NLP pipeline, you would have these different tasks that do different things to the input, maybe extract entities, and another one would do, find the relation between verbs and subjects and all that. Here you can really train end-to-end. And this reminded me a little bit of the breakthroughs that we've seen in computer vision back in 2012, when all of a sudden deep networks were really winning all the competitions. And if you look at what happened in computer vision research before this breakthrough, is people back then really would handcraft filters to extract meaningful information from images. And then sometimes on top of these handcrafted features that they would extract, they would learn a simple classifier. But in 2012, the big shift really was to move away from that and to train end-to-end, to go directly from the pixels to the quantity you're interested in, which could be classification or object detection or something like this. And with the transformers being a very, not just very powerful, but also very fast to train architecture, you can now do this end-to-end learning, but you can do it in the space of text or strings. And so I had this idea, but as I said before, typically you need a parallel corpus to train such a thing, and that really posed a problem. But before we go and talk about how I solved this, I want to briefly talk about the wonderful property that you have in transformers, and that arises from this concept called self-attention. So I guess most of you are familiar with word-to-vec. If you compute a word-to-vec representation based on text, what happens is that for each token or each word, depending on how you tokenize your input, you would have a representation, but that representation would be fixed. So for example, here, BMW would have a fixed representation, and also 2002 would have a fixed embedding. And what the transformer is doing using self-attention is it's actually refining iteratively over multiple steps, depending on how many transformer layers, how many blocks you actually glue together. It's refining the input representation based on the words that surround it. And one of the beautiful things is it doesn't actually need to be directly next to it. So you can really compare any word to any other word and iteratively refine the representation of a specific token given the surrounding text. And that allows you to capture context. And as I said before, one of the big advantages compared to the previous methodologies like LSTMs, for example, is that it also trains very, very, very fast, because these steps can be done in parallel and they don't have to operate over the input in sequence. They also don't try to cram everything into a single hidden state, which is what LSTMs do. But here you really have this powerful idea of context-based attention, where you refine the representation of a token. And to make this a bit more concrete, I have 3 more examples. So here the query was BMW 2002, and the system maps that to a correct make and model, because 2002 happens to be a valid model for BMW. And the next query, we're actually asking for BMW before 2002, and that's also being mapped correctly. And that's only possible because this little word or the little token before the 2002 actually updates the representation. It informs the model that this time we're actually looking for range query. And in the last example, we have a BMW below 2002 euros, so basically below 2000 euros. It's a bit of a contrived example, but you can see that the model still handles this correctly. And once again, it's only very small differences, but they lead to a different representation. And that is due to self-attention, refining the embedding based on the context. And that's really quite something very powerful. Now, another very powerful thing is that there's a lot of variety in natural language. So when you build a system and you put it out into the world, just a text box, there's basically no end to the variation that you're going to see from users. That starts with typos, but it also starts, of course, with slang, and then there is different ways, like synonyms, to express the same thing. And it's really powerful if you have a system in place that can simply learn the right mapping. So what you can see here are three fairly well-known makes. The correct spelling is in black, and you can see just a fraction of the possible variations that we've seen in the real world in white. And if you look at those for a second, it's going to become obvious that it would be extremely difficult to handcraft a feature extractor or to like capture this with a regex. And so with an end-to-end system, we can simply show the model inputs and the desired output, and the model just takes care of doing the correct mapping. But as I said before, one of the big problems is data. And in my case, we never had a search feature, which means I did not have any access to natural language input data. All I had were log files, millions of those, but no corresponding natural language input. And this, I guess, is why it's also fitting that I'm speaking at Hacking Machine Learning, which, by the way, is the first meetup I ever attended when I moved to Munich about 4 years ago. So I'm quite happy that I can speak here today with an interesting, hopefully interesting topic. And so my idea here was, what if I just take the log files and I write a simple script that tries to create some kind of natural language representation from the log files? So essentially mapping our taxonomy into some variation of natural language. Of course, fully understanding that this variation is going to be very limited and is going to reflect my own biases of how to express yourself in natural language. But that was basically the idea. So I spent a few weeks just diving into natural language processing. We already had this Hack Week prototype that really posed a problem for me, because it really challenged me to think, can I do something with machine learning that adds value, that's not just slower, more difficult to maintain, and more costly to operate in production than a very simple lookup mechanism that already captures, quite a few of the basic cases. And so the idea was to try to apply transformers, and by that I mean the original encoder-decoder architecture that was also proposed in the Attention's All You Need paper, and simply learn a translation from natural language to a structured search query. And so this is was about 2 years ago, and that is the framework I decided to use is called Tensor to Tensor. I'm not really going to go too deep into it, because if I were to start the project today, I would probably use a different library. And that's simply because we're living in amazing times, and the space of tooling and frameworks is moving very, very quickly. I mean, Hugging Face Transformers now has been around for quite a while, initially more focused on the BERT kind of embedding models with the associated downstream tasks of, for example, sentiment classification and that kind of stuff. But more recently, they actually also updated the library. So now you also have encoder-decoder, abstractive summarization and translation kind of tasks in there and models. And so that would be a library I would probably look at today. But back in 2018, Tensor to Tensor was the perfect library to use, because it actually was created by some of the authors of the original Transformers paper. So it contained the reference implementation, and every couple of weeks, I remember this, the fall of 2018, every couple of weeks there was a new paper with a new variation, and the code would just appear within a couple of days. Sometimes the code would appear on the GitHub repo before the paper was written. And it was just a wonderful time to just play with all these different models and see if they would apply to the problem that I was investigating. So these are just a couple of papers. Top left, you see the canonical attentions all you need paper, which is really wonderful. If you haven't read it, I can still strongly recommend it, even if it's an old one. And then all kinds of interesting subsequent work refining the transformer architecture. And as I said, all of this was also available in terms of models and hyperparameters in the tensor-to-tensor library. And that made it very easy to just experiment. So all you need to do is just install it using pip, for example, and then you would have a command that would generate your data. You could specify a model, for example, transformer, as a problem, which could be translation. You would point it to a directory where your data lives, specify a set of hyperparameters, and all of those were actually already included for the standard problems. Let's say you wanted to do English to German translation, you wanted to reproduce the results in the paper. It was guaranteed that you would actually be able to do that using the parameters supplied by a tensor-to-tensor, which is really great because this was, I think, before Hugging Face had the Transformers library out, and during these days it could actually sometimes involve a considerable amount of guesswork to really figure out how did the authors of a paper make it work. And then an output directory, this is where your trained model would then end up, and if you point TensorBoard to that, you can also monitor all your different training runs. But tensor-to-tensor also had another very nice property, and that is it was a one-line command to export the trained model to a saved model. And some of you may know, once you have a saved model, you can easily serve that in production using TensorFlow serving. All right, so ideation was in August. We had the non-machine learning based prototype in September. And during that time, I was mainly working on other projects, but just thinking about the idea. And I think it was around end of November when I decided I'm just going to give this transformer idea a shot. So just in time for the Christmas party in December, I had the first proof of concept ready. I built a little Flask demo, and I remember it was ready just a few minutes before the party started, and I walked up with my laptop and I gave it to people and just encouraged them to type in a query. It was really just a very simple page with a little text field, and the response of the system that was running, of course, on a server in AWS would then just be displayed in iframe. So it was just the iframe would just display the results from our normal website. And just like with the Hack Week prototype, this was very powerful because it helps get buy-in if you can put something into the hands of people and show them, hey, this works. It also reduces the downside for the product teams because if they know they have something they can just interact with, it's a simple API, and they hand over a string and they get back a URL. It just takes out the risk a little bit to experiment with that. But I feel very lucky that I got a green light from the PMs back then to just continue with this. Now, beginning of 2019, once again, I was working on other projects that needed to be done, but we went live with the first system in April. Now, going live, of course, requires a little bit more than just a demo, so I had to think a little bit about how to make this production ready. I also moved away from Flask, which is synchronous, which essentially means during the time that the model is processing a request, the Flask app can't accept any new requests. I moved that to Starlet, which is a wonderful framework, and I think it's even today, it's still a good choice. So I should mention that today I would probably use Fast API, which uses Starlet under the hood, but brings a couple of additional benefits. But anyway, so it's a very fast asynchronous framework, and that's basically the API component that people interact with if they use the service. And the second component just hosts the model. And as I mentioned before, here I'm using TensorFlow serving, which is still, I think, quite an amazing piece of code. It's just a little C binary. And if you point it towards a folder and then just drop a model into that folder, it's gonna give you both a REST and a like an REST and a gRPC endpoint. gRPC, of course, is super nice if you're interested in performance. Another nice thing that you can do with TensorFlow serving is you can do request batching, and that is really interesting in combination with the front end, with an app that is asynchronous. So that's actually what we're doing right now. The front end, so the API itself, is just accepting incoming requests, doing some transformation, tokenizing the input, creating a protobuf file, and then sending this off to TensorFlow serving. And the TensorFlow serving binary has been instructed to do request batching, so it's waiting a couple of milliseconds, gathering all the requests, and then crunching them at once on a GPU that is very powerful and allows me to handle spikes in requests very, very gracefully. So I still think TensorFlow serving is an amazing piece of software, and I have to say it's the main reason I actually decided to stick with the TensorFlow ecosystem and not use, for example, PyTorch, which was starting to become very popular back then. So this brings us to the first A/B test on web in Germany. That was April 2019. And it was actually an unusual A/B test because typically you run A/B tests to gauge how users respond to something that you build. But this A/B test was purely designed to generate training data for the system. As I mentioned before, up to that point, the system was only trained based on log files that, with help of our taxonomy, had been mapped back to some variation of natural language, but it hadn't been exposed to the variability and the real-world input that users generate. So this was what this test was designed to actually capture. And the idea here was, let me train a simple system, kind of bootstrap the system using these artificial queries, and then refine it in production using user feedback. And if you think about this, this is quite an adventure because it's an assumption, of course, that some of the users would, if they're not happy with the result they're getting, refine their query using filters. And the idea was that a user that corrects a query manually gives the signal to the system to actually improve. And next time, hopefully, you would do a better job at capturing the intent of the user. So quite exciting. And you can see a couple of more blocks, and these indicate all the changes that we've done since. And these involve things like rolling out 2 different platforms. So initially, we were just live on web. Now we're also live in the apps. We rolled out to all countries, which is also very exciting. It's the same very model that was trained on German data that we rolled out to the countries. And once again, initially, it didn't do the best kind of job because it just didn't understand certain things. It can now handle about 5 languages, but over time, using the feedback generated by real users, it kind of picked up on what people mean. And so the reason I show this little graph is to just illustrate it's not really only about the technical aspect of things. In this case, it was actually relatively easy given the fact that I was able to stand on the shoulders of giants with tensor to tensor. I had a very robust library and really excellent examples of how to train encoder-decoder architecture to just learn the mapping from an input to an output using TensorFlow serving. Even though I'm just a data scientist, I was able to provide a very reliable and scalable service for product teams to use. And the real questions, like the meat of things, actually lies with different questions. So it's quite a journey actually to go from this idea until the finished product. And it's interesting that I'm giving this talk today because just in the last couple of weeks, we've seen a massive increase in user adoption, which makes me very happy. So I think over the last 4 weeks, we doubled the amount of requests the API is handling. We see a huge uptick in use in countries like Italy, but also in Germany. And it's just super, super nice to see that people actually use the feature and that it's actually helpful for them. And The refinements, of course, they're still happening. The product teams are still trying different integrations and different ways to present this to users. Because in the end, what we have to do is we have to overcome learned behavior. For many years, people have searched platforms like ours in a certain way using filters, and now this is really almost like a learning experience to help users also use the new system in a way that they benefit from. But just to provide some context around this as well from the research perspective, so you see on the top left the paper that started All Attention is All You Need, and that was, as I said before, an encoder-decoder architecture. And the paper that probably really started the whole transformer craze was BERT, which focused more on the encoder representations. We illustrated how powerful these transformers can be to create embeddings from language. GPT-2 and also GPT-3 focus more on decoder, on the decoder architecture. They're more about language generation. And I mentioned T5 here because T5 is a very interesting paper that investigates essentially tries to disentangle why do certain papers report a new breakthrough. Because of course there was a flood of papers, and this is no way near exhaustive. There was a flood of papers coming out over these years showing new state-of-the-art results. And sometimes it's not easy to disentangle, are these results better because people used more compute, more data, or is the architecture actually better? And the T5 paper starts to investigate this. And they also use encoder-decoder architecture, which really had been forgotten, I feel, with the BERT craze, but it seems to be coming back. I also have a little note here indicating that in October 2019, Google Search started to use BERT to improve their search results, to improve their understanding of what users type in. And so this is basically the research context that we live in. So the last couple of slides, I want to talk a little bit about the questions that I'm currently thinking about. And as I said before, they don't really revolve around technical aspects. That's really done. So I settled on an architecture that I know is good enough. Model training is largely automated. The API deployment has all the bells and whistles, auto-scaling, alarming, everything you want. TensorFlow serving works really perfectly fine. Latencies are good. Request spikes can be handled fine. My interest is really in building or helping build a product that then is also used and that's successful. And that's why I'm so happy that recently we see this uptick in user adoption for the feature. And so these are really questions that are less about transformer blocks and embedding sizes and all that stuff. They're really more about how do I set up a system that ideally just gets better over time as a side product of people using the system. And that's really the dream. I mean, you have this for recommender systems, for example. As a side product of people just interacting with your website, you get all this rich data, and you can harness this, you can extract patterns, and you can provide recommendations. That's, I think, still the perfect data science product today. And what I was trying here is something similar. So after the bootstrap process, where I would just use log files, the hope was really that users would tell the system, would teach the system to become better over time. And that's actually, to some extent, it's an assumption, and it holds true. So I see users teaching the system surprising things. For example, there was a time it actually doesn't work anymore because the system is very fluid. It's a living system. But there was a time when you would type in shovelhead for the motor search, for the bike search, it would map that to Harley Davidson, I think until some specific first registration year. I actually forgot the details. I didn't know what a shovelhead actually is. I looked it up on Wikipedia, and it says it's a specific type of motor that was only produced in a certain amount of time. And actually the first registration year that the model had learned to map the description in Wikipedia. So that was super amazing to see that, as I was hoping, the model actually picked up and it learned things from our users. But another aspect is that now that we've been live for quite a while and we get lots of user interaction, the model has become fairly robust in the way it responds, and typically the response is good enough for most users. And what that means, if it's good enough, it means I get less and less corrective input. And if someone is happy with the response they get, today's response then becomes tomorrow's training data. So there's a balancing act. And the balancing act ties also in with what do we offer to our users. So as I said before, the initial search that we had, the old filter search, is extremely structured. You pick a make, and then you can only select models that are valid for that make. It's a drop-down menu. There's not even an option to make mistakes. On the other end of the spectrum, you have a completely unguided search entry, and that's what we had initially. When we went live back in April 2019, with the first A/B test, we just had a text box, no guidance whatsoever. And not only did this produce a lot of typos on the side of our users, it also means you can type in things that don't make sense, make model combinations that don't exist. And so in terms of helping the user to interact with a feature in a successful manner, which in turn will also lead to the generation of interesting training data, it's really key to find a balance between these two extremes. And we introduced a couple of small additions to try to navigate this trade-off. The first one is example queries. And this is basically the missing manual, because when we released the feature, there was no explanation. I think even today, there's no explanation. We just hope the users type something in and discover by playing with the feature. But so the example queries are meant to show the user what kind of queries the system can handle. So the first one is about just a type of car, so station wagon with a 4-wheel drive, telling the user essentially you don't even need to give us a make or model, you can also be more broad. Second one is about a make and a location, in this case it's Munich. The next two examples are about range queries, and it's actually the same number, but once it's kilometers and once it's euros. And I chose this on purpose in the hope that people actually realize they need to tell me if they mean less than 10,000 miles or less than 10,000 euros, because I don't know and the system also doesn't know. And the last example is a more complex query that involves a version, 2 colors, and a range query. So this was the first thing that we released to kind of move the needle a little bit back from completely unguided. The second feature we added was autocomplete, and that was mainly done to help users make less typos, which of course in turn makes it easier for the system. Interestingly, people still make typos, and I'm not quite sure if it's because they type so fast that they don't even have time to look at the suggestions that come from autocomplete, or maybe some of them talk to their phones. There's also very funny mistakes sometimes that I'm almost certain come from Siri or from some kind of Google service translating speech into text. And some of these mistakes are now automatically corrected by my service. So it's kind of funny to think about this, how the different machine learning models interact with each other, and one is trying to correct the mistakes the other one made. And autocomplete also ties in with suggestions. So the way I set up the autocomplete service is that it only, in contrast to what Google is doing, I think Google tries to always complete your query string no matter what you type. But of course, they also have a lot more data to build such a system, to base such a system on. What I'm trying to do here is I'm trying to complete the query with examples that we've seen real users utilize on our website. So it provides back some guidance by steering the user towards queries that other people have used successfully on our website. But as I said before, it's still completely unbound, and we still see an enormous variety of different inputs. So it's a very interesting journey we are on, and it's still kind of an adventure because the system keeps evolving. We're releasing on more and more different places, and now that we are live in all these countries, there's also interesting things happening around different languages. And that really brings me to my last slide. It's kind of an outlook, and it's what I'm thinking about most these days. It's really how to find a way to help the model escape from local optima. And by local optima, I mean, if the model has figured out a way to respond that's good enough for most people, then it's very hard to get out of that, because today's response becomes tomorrow's training data. And if it's good enough, nobody's going to set a manual correction, or very few people are going to manually correct this input. So it becomes this self-reinforcing thing. And the question on my mind these days is really, how can I nudge the model? How can I nudge it towards better and better performance? And that sometimes means the model needs to forget old habits. And that's non-trivial, because these old habits are encoded in the old responses, and they're the training data. So that raises interesting questions around, do we start discarding old training data? Do we manually correct some of the old training data? And these are the questions I think about most these days, just to ensure that the model keeps improving, it keeps evolving, it keeps doing a better job over time. So hopefully at some point it's going to be live on all platforms, and it's going to be possibly even a reason for you to start your search on AutoScout24 and not on one of the other platforms out there. With that, I'm concluding. I'm happy for questions. And I should also mention that if you're interested in doing end-to-end data science work, and by end-to-end I really mean going from an interesting business problem, kind of moving it around in your head and thinking what kind of machine learning algorithm could you apply to that, way towards the productionizing, and then even shepherding the product through its different phases in production. So if you're interested in this end-to-end work, then feel free to reach out to me. We are currently hiring in the data science group. You can just talk to me on LinkedIn, and I can tell you a bit more about the positions we have open. All right. Thank you, Dan.
It's amazing. I really like your talk. It's so, on one hand, it's like very end-to-end, as you mentioned, right? Because you start from what's a story, right? And after you're covering many different like milestones, but it's also like very rich and detailed, right? So I definitely did enjoy, and we already received like some questions from the audience. So I will just like, slowly jump onto that. So first question is coming from Fabi. I'm not sure what is the full name, but essentially, how does the user feedback loop work? How does the user interaction becomes a training data? Like if you can elaborate a bit more on that.
Yeah, sure. So when the system is live, we have the string that the user typed in, and we have the response that the model sent. And then we know if the user was happy with that response, and that if he was happy, it means basically he interacted with the results page. Because all it's really doing, it's, as I said before, it's setting filters for you. So it basically, you type something in and the system brings you to our search result page. Now, my assumption, and I think it's a good assumption, is if you're happy with this, with the search results, you're going to interact with a list. You're going to click on a listing. And that's something we capture, of course. And then I have a positive training signal. I know that the translation the model just produced was good enough for a user to then interact with the listing. So this is the feedback loop. This is the positive feedback loop. The second one is if you're not happy enough and you start to add manual corrections to the response that you got, because you still have the filters available to you, that's a signal for the model that it should actually have translated something differently. So there's both positive feedback and there's corrective feedback. But the balancing act really is, if your model is already good enough for most users, how do you still encourage them to nudge it further and to help it get better over time? And that's still, to some extent, an open question.
Mm-hmm. Do you do any kind of, maybe a follow-up from my side, do you do any kind of like a negative mining, right? So you kind of know what examples don't get any interactions, right? And you can just say like, hey, I don't care about them, right? But you can also say that it's also like where your model is like completely off, right? Because, if you're searching for, I don't know, like a Porsche panorama, right? And it's like finding the cars with like panorama view, right? The user can be like, hey, right? And after you just like have a bounce, right? And from there, you don't really have a correction, right? But those might be the most wrong ones, right? Is it something that make sense, or majority of the users anyway do correction, right? And after you don't have such a problem like in your case.
So, I mean, the most obvious mistakes the model shouldn't even do anymore. It's really working quite well for a vast amount of queries. So if the output was not good enough for user to interact with the results page, this is currently not accounted for. So there's no penalty, so to speak. Because it could be multiple reasons. It could also be you just looked at something and then you didn't like the prices, or your doorbell rang or something like that. So it doesn't necessarily mean that the translation was actually bad.
Cool, sounds good. And maybe just like a short one on that one regard as well. How frequently do you like retrain with the new input data, right? Because on one hand, I can imagine, depending like how many queries doing the corrections, right? You can do it whatever, like daily, monthly, right? But you also need to be really careful with the learning rate, right? Because you can be just like almost like vanishing all information that was like learned before, right? So how do you, on one hand, tune it, right? And is it also depending like on amount of like training data points, right, that you're receiving? Like how do you in general look at this process, and how do you bootstrap it from there?
So right now I'm training about once a month. And it's interesting because initially I thought this bootstrapping of training data is just going to help the model to get going. And at some point, I'm just going to switch completely to only using real world data that I get from users. But it turns out it's still useful. So I'm still using a mix of real world data and of artificial data. And artificial data has the positive effect of kind of anchoring the model towards something that actually makes sense. It's grounded the model in our taxonomy, which is also good because there's new make model combinations appearing over time, and some of them, when they freshly appear, they're not really being used in search as much. So that really helps the model to quickly pick up on things that haven't existed before a few weeks. So it's a mix of both.
Nice, very good approach. So another question is coming from Tanja. She's asking like, hey, what exactly is the input to the model? Just a user input, or also some kind of the database features?
So the input is really just what the user typed in. It's just the raw query string, which could, as I said, be anything. Some people look for pets or for all kinds of crazy things, because they kind of mistake us for Google. So it's just what the user types in.
And do you, on the other side, generate, let's say, I don't know, you're getting something about like BMW, right? Do you get IDs, right? Or you just kind of trying to normalize in some things that afterwards can be parsed by regex? Like how structure your translation is kind of becoming, right? Is it like, I don't know, brand ID equal blah, I don't know, something model ID equal like another ID, or what do you get there?
So the output is exactly what you would get if you just go to our website using the normal filters. It's just a URL.
Okay, so basically with IDs, right, and everything else.
Right. So that's what I was referring to earlier. So initially, when I was thinking about what can be done with machine learning, I was also thinking about, as I said before, embedding maybe the queries and the items in some vector space and then doing some search there. But that would have meant I would create an alternative search stack, competing search stack to what we already have live on our platforms, and that's just not a very good idea. And so I decided to just map it into a representation that can be handled using the existing search stack. So that also means, if you think about it, it means that there's a limit to what the model can actually learn or what it can express, and that limit is what we can express using filters.
No, that's great. I mean, for me, it's always exciting that such translation is even possible, right? Because you definitely know, hey, transformers are powerful, but when the model is like able to memorize all of those things like to such a degree, it's like really good. Maybe like a short follow-up into that, right? So you mentioned that people typing all kind of like a not related, let's call it like that, to your search domain space, right? Do you do any kind of like a filtering out of distribution, right? Or you send everything to your like expensive transformer model, and after it just like yielding something that like, hey, it's like out of distribution? Or how do you handle this problem? Because I guess, you know, if you just ask GPT-3 no matter what, right, it's going to answer you no matter what you did ask about that, right?
Yeah. Well, I guess the key difference is that GPT-3 has been trained on an extremely wide corpus, and it's trained to generate unstructured output. So we have the interesting problem where the input is almost unbound in terms of variability, but the output is very structured. And so I've never seen the case where the model just starts hallucinating and say something, like respond with something weird. There's always going to be something that relates to our taxonomy, which may or may not make sense. But we're actually sending all queries to the transformer model. It's not even that costly. I guess we're also not using a model. If you read about these crazy models that have been released recently or not even released publicly, that only very few institutions can even train because they have billions of parameters. Ours is a lot smaller, and it's not so costly to actually send all requests directly to the API.
But in general, just like to follow what you're saying, your model still maps it to some kind of like a search string, right? So if somebody is searching for BMW like cat 5, right? I mean, I hope there is not a model like that, right? It's still gonna like find something that is like the most closest, right? You don't have some kind of like I don't know, like unknown, like as a placeholder, so that after whoever is like handling the model can say like, hey, it looks like that is out of distribution, right? Please forward it user to, I don't know, the page with exploration of the brands, right? There's nothing like that. It will yield anything, right? Because if you have a softmax, it's just gonna show whatever is like having the highest probability there, right? Is that correct?
Yes. So right now we don't have that. It's something I was thinking about including because the model gives me back both a response but also a score. And the score kind of tells me what you already alluded to, how likely is it to encounter such an example. So there's some inputs that still surprise the model, and you could actually make use of the score and think about a user interface where you would alert the user to this being a very unusual search string. And if they really meant similar to Google saying, did you really mean this or did you mean to type something else? Yeah. And that is one of the possible refinements that I'm thinking about.
Nice, pretty cool. Awesome. The next question is coming from, I guess, Maravan. He's asking, like, how do you deal with the new car models where you don't have training data for the mapping?
Yes, this is where retraining comes in, and also this aspect of having part of your training data generated from the taxonomy. So as soon as there's a new car model, it's going to be in our taxonomy, and I can generate at least a couple of examples. Which means there could, of course, be a few days where a new model is live and I can't handle it yet, but it should not be more than a couple of days.
Your embeddings, maybe just like short follow from my side, are they like on a word level, or you also do like a sub-word parts, right? Because in this case, I don't know, you might still have something that you have seen before, right? Although like you need to map it one-to-one, right? So it's not really might be helpful to have some proximity.
Well, it's encoder decoder. So I use subword encoding, and it's useful to handle typos. So if you get all these strange typos, some of which I've shown earlier, then maybe at least 2 or 3 characters are actually correct, and then the rest is not correct. So that helps the model. Yes. But the fallback would always be to just reconstruct the entire input based on a character level. So the raw the alphabet is always part of your vocabulary. So the model can actually both understand and also reproduce, for example, in the version field, things it has not seen before, just by operating on a character level.
Nice, pretty cool, awesome. And the last question again coming from Fabian, he or she is asking, like, did you get the chance to test GPT-3 on this task yet?
So I didn't get a chance. I haven't applied to use GPT-3. It would be interesting, I guess, because it knows a lot about how humans express themselves. But it also knows very little, I would assume, about our taxonomy. Now, I've read the paper. It's super amazing what they can do using zero-shot learning. But in our case, it's still super specific. And the URL actually needs to be correct in order to be executed properly. So even slight modification would then would cause the query to fail. And I would actually, my gut feeling tells me GPT-3 would not work out of the box. It could work probably using some kind of retraining, but I think it is probably overkill to use such a massive model for this task, which is a bit simpler. And it's in a very specific subset of the globe, so of the application space. I think GPT-3 is really very universal. But it would be interesting to play with it.
Yeah, it's really, I don't know. I mean, like using GPT-3 in production, I think is completely different discussion, right? But what I've seen recently is that people were trying to train, let's say you have like a database structure, right, with the tables and columns, right? And they were feeding it, I think, like as a schema. And after they were feeding a couple of like human language queries, right? And after GPT-3 was like able kind of figure out like how to query those tables, right, and how to do all this like grouping given the schema, right, of the table. So I don't know, it's crazy. And another example, go ahead.
Yeah, but I think there must be some SQL query examples that GPT-3 has read.
Yeah, definitely. Yeah, it's read like a lot of internet about.
Probably doesn't know too much about our taxonomy.
Yeah,
so it's probably going to be more difficult to apply to our use case. And
just like another example, I think it's actually was like Vincent from Rasa as well, like was sharing at some point that there was some app that also do more or less like your terminal commands, right? But you like us looking at like in text, and after all of the thing is like executing like under sudo, right? And somebody was like tweeting is like, are you sure that you want to do that, right? I mean, it can map to some like output space, right? But you can just like explode in your face, and nobody will like ever see like what's happening there. So another question from Antonio Rossi, maybe a bit provocative. Can it be the case that users are interested in using the smart search because they expect something smart from it? Example, something that is not possible via filters. Do you think it's a bit of like can be, you're catching like many meanings, right? But after you cannot describe it through the interface of like general filters that you have behind.
So I think it's quite possible that users expect it to do something that you can't do with filters. And this is not what I intended when I pushed for the naming smart. In my mind, it's a smarter way to start your search, but it's quite possible that some users expect it to do more than just set filters for you. Sadly, it can't right now.
Maybe the next step, Cool. It was an amazing talk and even more amazing answering of the questions. Now I guess we can have like 5 minutes break, right? And just continue with the shared. Whoever is from our members on YouTube would like to join on Hangout link, right? I shared it via Meetup and also going to share it in comment section. So please just join us there. And thank you again, Markus, for this phenomenal talk and for a great time on this Thursday evening. So let's talk in a bit. Let's have 5 minutes and talk to you there. A good one.
Cool.
Yeah, and for all people on YouTube channel, as I said, I'm going to share the link to Hangout and we can meet there in 5 minutes. So hopefully you can ask your favorite questions to Markus and Tanja in a bit more private setup, right? Yes, I shared also the link in the comments. So let's meet up there. Thank you for everybody for joining us and talk to you in a